Hello students, I'm back with a new video and this is about how do we recognize a conic. So I have written recognition of conics here, and you know that a line is represented by a linear equation, and that is ax plus by plus c is equal to 0. That is the maximum power of x and y is 1 here. But for conic, we should know that all the conics, that is circle, parabola, ellipse, hyperbola, and plus pair of straight lines, all are represented by second degree equation, and that second degree equation is this: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So first of all, pair of straight lines is written here. What that means, if we multiply two lines, suppose these are two lines, and product of two lines comes out to be a second degree equation of this type. Now look, when I multiply this x with x, I get x square, and with 2y with minus y, I get minus 2y square, and here further I get minus xy plus 2xy, that is xy, 3x plus x, that is 4x, and this is 6y minus y, so this comes out to be 5y, and 1 into 3. So this is what a second degree equation, which includes x square, y square, x into y, x, y, and a constant here. So this is similar to this type of equation. And easily we can find out a is here coefficient of x square, that is 1. B is coefficient of y square, that is here minus 2. 2h is what the coefficient of xy, so here I have 1, so h comes out to be 1 by 2. 2g is here 4, so g is here 2, and 2f is here 5, so f is here 5 by 2, and further c is here 3. So what if this equation, the second degree, we have to recognize whether this equation is of a pair of straight line, then in that case this must satisfy this, that delta and delta is the necessary and sufficient condition for this equation to be of pair of straight line. And what is that delta? Delta is abc plus 2fgh minus af square minus bg square minus cs square is equal to 0. If you are not able to learn this, then you can learn this in this form. Delta is here, just write these ABC diagonally, and alphabetically order, in alphabetical order we have F after ABC in this second degree equation, so write F here. Then we have G, so write G here, and then we have H, so write H here. So this is how we learn delta. Just write diagonally ABC and then fill these blanks by FF, GG, and HH. And this is equal to 0. When we solve this, I get this. So this is what the necessary and sufficient condition for this second degree equation to be of pair of straight lines. Now next is written here circle. If the second degree equation is of circle, then in that case delta should not be equal to 0, because delta is equal to 0 is only for pair of straight lines. And plus one more thing, you know that circle is of this type: x square plus y square plus 2gx plus 2fy plus c is equal to 0, or x minus h whole square y minus k whole square is equal to r square. In this case, we don't get x into y terms, because when we resolve these whole square, we get x square, y square, x, y, and a constant. Therefore, in this second degree equation, h should be equal to 0, so that this equation can be of circle. So I put h is equal to 0. One more condition is here, that the coefficient of x square should be equal to coefficient of y square, then only this be a circle. That means here coefficient of x square is a and coefficient of y square is b, therefore a is equal to b. So necessary and sufficient condition for this second degree to be of circle is delta should not be equal to 0, h is equal to 0, and a is equal to b. Then for parabola, Again, delta is not equal to 0 because delta is equal to 0 is only for pair of straight line, and rest all these conics depends on only on h, a and b. So for parabola, this h square should be equal to ab. Then for ellipse, delta not equal to 0 and this h square should be less than ab. Then we have hyperbola. So for hyperbola, just reverse this sign. If this less, then if in ellipse we get sign of less than, then just replace this sign by greater than. All the results are converted into hyperbola by changing less to less by greater, plus by minus, minus by plus. We can easily convert all the results of ellipse into hyperbola. Now, for rectangular hyperbola, this delta not equal to 0, h square should be greater than ab, and one more condition, and that is a plus b equal to 0. Then for pair of parallel lines, as this is of pair of parallel lines, therefore delta should be equal to 0, and one more condition, that is h square is equal to ab. This condition is similar to parabola, but in parabola, this delta is not equal to 0. And in pair of straight line, delta is equal to 0 plus h square is equal to ab. For parabola, delta not equal to 0 and h square is equal to ab. Okay. Now for pair of parallel perpendicular lines, again delta is equal to 0 and a plus b is also 0. So this is similar to this rectangular hyperbola. In rectangular hyperbola, again we have written a plus b equal to, but delta is not equal to 0 in that case. And for pair of intersecting line, delta is equal to 0, but h square is not equal to ab. So this is how we recognize a conic or pair of lines, types of pair of lines. One more condition depends on this, that is if we have to check the eccentricity of the curve, again we have to learn this table and we have to apply these results on that, because eccentricities are fixed. In case of pair of straight line, eccentricity is infinity. So if that curve comes out to be pair of straight, or if that second degree equation comes out to be of pair of straight line, and what we have to find the eccentricity, then eccentricity of pair of straight line is, first we check whether that is of pair of straight line, and if they ask for eccentricity, then in that case eccentricity is infinity. For circle, eccentricity is 0. For ellipse, eccentricity is 1. For parabola, eccentricity is 1. For ellipse, eccentricity lies in between 0 and 1, that is less than 1, but is always positive, therefore is in between 0 and 1. If this eccentricity is less than 1 for ellipse, then for hyperbola, we just reverse the sign, e is greater than 1. And eccentricity of rectangular hyperbola is fixed, that is root 2, greater than 1 but is fixed, that is root 2. And rest 7, 8, 9 are pair of straight lines, so eccentricities for all these three cases are infinity. E is equal to infinity, E is equal to infinity, and E is equal to infinity here also. So what type of question we can apply this result, and what types of question? Now first question is written here: x square minus 2xy plus 2y square plus 2x plus 4y plus 1 is equal to 0 is the equation of whether this is of circle or of parabola or of ellipse or of hyperbola. So we have to check the curve. So in that case, there is no option of pair of straight line, because checking pair of straight line is quite difficult. We have to learn this condition, that is abc plus 2fgh minus af square minus bg square minus cs square is equal to 0, or we have to use this determinant. So if there is no option of that type, so rest all are depends, this all circle, parabola, ellipse, hyperbola, these all depend on h, a and b. So we have to just compare this second degree equation with this ax square 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So from this given equation, a is equal to 1, that is coefficient of x square, b is equal to 2, that is coefficient of y square, and 2h is equal to minus 2, that is coefficient of xy. So h comes out to be minus 1, and when I square this, h square is equal to 1. And when I multiply a and b, my answer comes out to be 2. That means h square is less than ab, and this is condition of ellipse. So we take third option. This is for ellipse. H square is less than ab is for ellipse. So this is how we just recognize the curve and take the option. Now second type of question is here. If the equation of circle is given to be this, and we have to find the center, and you know that if this is what the general equation of a circle, x square plus y square plus 2gx plus 2fy plus c is equal to 0, and center from this is minus g minus f is what the coordinates of center, and radius is r is equal to root of g square plus f square minus c. But if they have given that this is the equation of circle, so this must satisfy the necessary and sufficient condition, that is delta is not equal to 0, h is equal to 0, and a should be equal to b. So what we do in this case, coefficient of x square is for this second degree by square plus 2gx plus 2fy plus c. This to be circle, if delta not equal to 0, a is equal to b, and h is equal to 0. In this question, coefficient of x square is a, and coefficient of y square is 2a minus 3, and a is equal to b. After applying this condition, I get a is equal to 2a minus 3, and from here I get a is equal to 3. So a comes out to be 3, and when I put this in my equation, then this comes out to be 3x square. I'm just putting a in the question, so this comes out to be 3x square, 6 minus 3, 3y square minus 4x minus 1 equal to 0. And in order to find center, first I have to divide it by 3. So this becomes x square plus y square minus 4 by 3x minus 1 by 3 equal to 0. And from here, what I get, 2g is minus 4 by 3. So g comes out to be minus 2 by 3. And 2f is here 0. So f comes out to be 0. But center is minus g minus f. So my center is 2 by 3 comma 0. So answer is second option. Now, what else is written here? Now in this question we have to find the eccentricity of the curve, and curve is given in parametric form, and in parametric form there is a variable, and in order to find a curve we have to, in order to find a curve, that is the locus, we have to eliminate that variable from these two, using these two equations. And when we get that curve, equation of that curve, then we can easily find out the eccentricity of that curve, because eccentricities are fixed. So how do we do this? We just eliminate t from these two equations by using these equation. So how do I eliminate that? I just take the value of t from equation 2, and that is y minus 1 is equal to 2t, and further y minus 1 upon 2 is equal to t, and I just put this value of t in equation 1. So this is how I eliminate. In whatever manner you can eliminate, by squaring, adding, by squaring, subtracting, by dividing, by multiplying, you just eliminate the variable, and when You eliminate that variable, you get equation in x and y, and that equation is the equation of curve or the equation of locus. So when I put this value of t in equation 1, so this equation reduces to, this is y square plus 1 minus 2x upon 4 plus 1, and when I take LCM, this is 4x is equal to y square plus 1 minus 2x plus 4, and this comes out to be y square minus 6x plus 5 equal to 0. Okay, sorry, this is minus 2y. So my equation comes out to be minus 2y. And further solving, I get y square minus 4x minus 2y plus 5 equal to 0. Now I have to check whether this is an equation of circle or parabola or ellipse or hyperbola. So easily we can check that this is not a circle because there is no x square written here, because for circle this a should be equal to b and h should be equal to 0. So first of all we just find out h, a and b, and from this equation a is what, the coefficient of x square. So here there is no x square, therefore coefficient is 0. Coefficient of y square is b, so b is here 1, and coefficient of x into y is 2h. So here there is no term containing xy, so 2h is here 0, so h is here 0. And what I get, h square is 0 and a into b is also 0, so my condition is h square is equal to ab. So this condition is satisfying here. So 0 is equal to 0, and that for that this curve is a parabola, and eccentricity of parabola is fixed, that is 1. So my answer is first option here. Next question is, again you have to identify the curve, and the curve described in parametric form, that is x is equal to t square plus t plus 1 and y is equal to t square minus t plus 1. So again I have to eliminate t, and as I eliminate t I get equation in x and y, and that is my curve. And then we check by taking values of h, a and b. Now from these two equations, how do we eliminate t? This is your equation 1, this is your equation 2. So first of all, if I add these two equations, I get x plus y is equal to 2t square plus 2, and x plus y upon 2 is equal to t square plus 1. So this is my first equation. If I subtract 2 from 1, then what I get, t square cancelled out, and here I get 2t, and 1 get cancelled out with each other. So what I get here, x minus y upon 2 is equal to t. Now from 4, put the value of t in equation 3. So when I put this value here, I get x plus y upon 2 is equal to x minus, when I put this value of t here, x minus y upon 2 whole square plus 1. And further, if I take LCM and this 4 comes here, I get this 2x plus y, and here I get x minus y whole square plus 4. And further solving this, I get, this comes out to be 2x plus 2y, and this is x square plus y square minus 2xy plus 4, and this comes out to be x square minus 2xy plus y square minus 2x minus 2y plus 4. Now there is an option of pair of straight line. For that we have to check delta. Now I'm just comparing the values of this equation, what I get? A is here 1, that is coefficient of x square. B is here 1, that is coefficient of y square. 2h is here minus 2, so h is here minus 1. 2g is here minus 2, so g comes out to be minus 1. 2f is here again minus 2, so f is here minus 1. And c comes out to be here 4. So when I check delta is here abc plus 2fgh minus af square minus bg square minus cs square is equal to 0. So when I put these values, I get 1 into 1 into 1, and then 2 into minus 1 and minus 1, then 1 into 1 minus 1 into 1 minus 4 into 1, and after solving this I get this as minus 9, which is not equal to 0. Therefore this is not a pair of straight lines, not an equation of pair of straight line. So now rest depends on h, a and b, and when I check, delta is not equal to 0 here, and h is here minus 1, a and b. So h square is here 1, and a into b is again 1. And this is what? When h square is equal to ab, then my conic is parabola. So my answer is third option. So this is how we recognize a conic, and after recognizing it, we can check its eccentricity. So I hope this video will help you a lot. I'll be back very soon with few more videos. Please subscribe the channel method wise and give a big thumbs up.